Good morning and welcome to part 2 of my Dissecting the System Engineering Criteria videos. Today what we are looking at is Criteria 2. And as you can see here, we're still talking about things in reference to this this picture here, the social distancing laser hat. Alright, so above me we have the researching, devising, designing and modeling design options criteria. This is criteria 2. The indicators of which are that we can see evidence of research, that you've tried to create models of components, subsystems and full systems. You've generated design ideas. You've done feasible design options. So the idea is that you are required to produce at least 3 different potential ideas to answer your design brief from criteria 1. All right? They must be feasible. They must be possible. There's no point in saying, oh, I'm going to make, make 2 things that are impossible to make in time, and then a third one and go, oh, I'm just going to make that third one. You are still required to make 3 possible designs. All right, I'll give you an example of what those might be in context with the hat. And then you need to select the preferred option. Now, part of that is that you explain why you have selected that option. So you have to come up with a reason why. And generally what we do is we are assessing our design against some of the criteria that we set up in the previous thing. Now, in the context of 2020 students, what you will need to do is you will need to operate under the assumption that you are still making the whole thing. All right, so your 3 design options should be a complete system, a complete project. And then as part of that, you will select the preferred option. And then as a further step to that, you will say, okay, because of the requirements of the 2020 study design, I'm going to make this part of this option. All right, I'll give you an example of what that might mean in the context of the hat, and we can discuss this one-on-one if anyone has any issues for their own context. All right, so I've got the GIF here for us to see what the user has made. So this is an inspiration. This is not what mine would look like, but still it's enough of an idea to explain what I want to do. So what I'm going to have to do, if I go to my document, I'm going to take this and I'm just going to pop this out of the way, pop it up there. So in here, now obviously I'm not going to be able to do all this live literally for you right now. However, I will make some annotation notes to this. So conduct research, including modeling of components. So what you should have in here are things such as potential parts. So in the context of this project, the laser hat, you might want to look at the different powered lasers. You would have to sort of explain which ones are safe, which ones are not safe. You might want to give examples of the costs of the different sorts of the lasers that you can get. Safe for use. Costs, etc. You might want to look at, how am I going to spin how am I going to spin the laser around? So you might think, well, okay, what sort of motor am I going to use? Since ideally I want my laser hat to be able to adjust itself based on how high the user is, so it's going to adjust the angle so that I can still get that 1.5 meter radius circle being generated around me. So I'm going to need to use different for angle of the laser, power supply, the Arduino, for example. I'm going to need to have the Arduino is going to have to be somewhere on that hat, but remember, because it is rotating around, I am going to need to have a way of connecting it all up so that the constant rotation isn't going to break things. Alright, which means that getting the power supply is going to be tricky because, again, this is going to be rotating very quickly. Therefore, I can't rely on having any cabling that will need to twist with it because it's not going to be possible. All right. So connecting everything in a rotating design. So if we scroll down, generating design ideas. So I actually came up with a picture that I happened to draw. I'm trying to think when I drew it. I believe I drew it live. I did do a live drawing of this, if I can find it, while I was at a different systems thing. Don't tell me I can't find it. Oh, I know where it is. Sorry, never mind. It's on my whiteboard. All right, here we go. Insert picture from this device. This is my very rough drawing that I made. So you guys will need to do some drawing to create some diagrams of what's going on here. As you can see here, I've got some measurements in here marking out the 1.5 meters. I've got a very brief explanation for what's going on. And then I've got in the top right corner there, I've got a zoomed in version of what's actually happening in terms of adjusting the angle. Now, what I've also got in there is I've also said I'm going to use a turntable to try and rotate things around. Don't know why, I just wrote it that way. So this would be one possible design option. All right. So what I would also have to realize is looking at my diagram and have to realize, well, okay, I need a different way of how the height of the user to determine the angle of, or to determine the angle that the laser requires. All right, so obviously the different, as the user goes up, the angle that the laser needs to be at for 1.5 meters will get slightly shallower, but for a short person, that angle is going to have to be quite steep. All right, so as you can see here, as the person increases in height, the angle will need to get smaller and smaller because it doesn't need to go past 1.5 meters. All right, so you would need to produce sort of 3 feasible design options. And then if you go back to the criteria, these are my ones that I came up with last time, very roughly. So it doesn't have to be in, for example, here I've come up with this sort of hat. But notice here in my design brief, I haven't said it needs to be a hat. I'm going to make it a hat, but my design brief doesn't say it has to be a hat. So I could also in here sort of say, well, okay, what if I have a laser belt? What might a laser belt look like? All right. Or it could be some sort of weird arm guards thing that projects out the distance. All right. And you could come up with these different design ideas. You could do some diagrams for them. You could come up with some sort of examples of the parts that you require for those. And then as part of the preferred option, you can go, well, okay, these are the problems with a laser belt or a arm guard system. That the hat doesn't have these problems because the hat is centered. We want our social distancing exclusion zone to be 1.5 meter radius circle. If it's centered on the person and it's on the head, it's always going to be in the same place relatively, meaning it will always be a nice even 1.5 meter circle. The belt might impede the user somehow because it's going to have things rotating around them all the time. You know, there are different ways of coming up retroactively some alternative options. All right, and that's going to be part of what you guys are going to have to do for your projects as well. Now, in regards to the 2020 thing, you are required to create an aspect. So in here, when you are selecting your preferred option, you would say, I'm going to select option 1 for these particular reasons. You have your own explanation criteria. You mark yourself against criteria previously. And then you would say, okay, as part of this, I'm only going to, so in the context of my laser hat, I'm only going to make the system that rotates to create the circle. I am not going to include the angle adjusting component. All right, because my laser hat would have 2 distinct aspects. One, the generation of the circle, and 2, the adjustment of the angle for this to create a different size circle depending on the user. All right. I see a couple of questions. I will get to those once I finish recording. All right. So, with all of this in mind, the criteria for high scoring ones that we're looking like is up there. Undertakes research including modeling of components, subsystems, and processes to generate design ideas using diagrams and technical data to justify feasible options and the preferred option. So you have to be able to justify why something is possible. All right. So material for the things that you're making things out of is part of it. All right. They are components. So if you're making a particular thing, you want to say, well, okay, the hat that I'm wearing should be made out of, I could make it out of a scooter helmet. I could do it on top of a felt hat, but I might say, well, okay, for structural ease of construction, I'm going to use a scooter helmet for the hat, similar to what's in the picture. And it's a pretty self-explanatory reason why you need a strong, stable surface to mount everything onto.